I'm Al George, one of the systems engineering faculty. And I'm really happy to be able to introduce Michael Moore to you, who will give us today's talk. He's a professor of energy economics and a senior fellow at the University of Calgary Institute for Sustainable Energy, Environment, and Economy. He was formerly the chief economist of the National Renewable Energy Laboratory, the United States one, in Golden, Colorado. And before that, he was a commissioner with the California Energy Commission. He served as an economist. He was the economist of the commission, and in that role he oversaw market structure issues, pricing of electricity and natural gas, and data collection for the commission as presiding member of the Electricity and Natural Gas Committee of the commission. And he specializes in research on cross-border regulatory issues affecting energy industry, and he teaches microeconomics and energy policy. Michael?
Thank you. Thank you, and thank you for having me here. I'm pretty honored to be part of your academic discussions, and I certainly have felt, I will say, very well treated while I'm here, or while I have been here, and hopefully that some of the contributions that I have been talking to people about will come about, and I'll be able to spend more time with you and more time with the groups in the future. I want to do really just one thing today. I want to get you thinking about the issue of what happens when we anticipate events in the energy world. And by the way, this is, because of my background, this is largely focused on energy and what is going to happen with some changes that I can forecast in the market. And so my question to you at the end, and I'll re-ask it at the end, is whether or not forecast changes in a very large potential fuel supply and reactions to that in nations all around the world is going to change the amount of invested and potentially stranded capital assets that we have in the electric system already, and whether or not, if it doesn't happen, we have a problem trying to recover and restabilize the system. So I'm going to talk about energy today, but in a sense it's just a foil. I've listened to a number of discussions that Al has led about systems engineering, and I come to appreciate that I have ideas about how systems interact, but I don't always have informed opinions about what might change in order to make them better. Well, in this case, I do have some informed opinions, and I'll talk to you about them in the form of who makes decisions on energy projects and who makes decisions that affect capital markets, because after all, in the energy world, all of these investments are very long-lived. They are very resistant to change. They don't change their characteristics very easily or very often, and they do so with a set or an intended characteristic of performance in mind at the time that they're built or at the time that they're acquired. So in that sense, dealing with systems thinking, I'm trying to imagine that the energy system, in spite of all the sophistication that we build into it, is in fact something that operates with limited and incomplete knowledge, that you certainly wouldn't have predicted the event last night, would you? That a technician could trip the entire Southwest, and yet that's happened before. And so as a consequence, maybe we should have built it in. Do we need extra redundancy, or is that simply an expense that we can't bear? We have limited and incomplete knowledge about some of the outcomes that we have. More important, we have overlapping and conflicting goals, objectives, and actions on the part of the approving and oversight agencies, and that's where I will try and dig into removing some of the uncertainty that's associated with that and trying to create or argue for a different appreciation of the risks in managing the electric system overall. My foil here is natural gas, and I will tell you that although I'm going to offer you just some context slides and graphs to set the background. In no way am I going to try and venture into the question of whether or not unconventional gas is appropriate or not, or whether it has been adequately characterized or not. In that sense, at least for this talk, I'm agnostic. All I care about is that, in fact, a lot of material has been published about it, and a lot of decisions have been made on the basis of that, from forecasters all the way down to investors. So in the background here, let's just see if I can make this work. I'm going to tell you that energy business is all about the business of making decisions where outcomes are pretty uncertain. I've already alluded to that. And I'm also going to try and at least convince you that it's possible that we need a change in the decision process because it's not reacting very well to the system that it's faced with. And we can do it by finding something that's a little more transparent and a little more open to change. So here I'm going to focus on capital expenditures in a world of flux, and that flux, by the way, is something that I called gas world. And I called it that in part because there are a lot of decisions being made in various countries that say, well, if gas is going to be so much more abundant, and today it's at $3.96 or so, $4, and tomorrow it's at $4, and don't know what it's going to be in a year, but I guess it could get up or it could go down. It's a pretty volatile commodity. And so if it's around as much as we think it is, and it's cheap, then we ought to just take advantage of that and replace a lot of the other stock that we have that's irritating for a number of different reasons. So I'm going to deal with a world that has a lot of things that weren't forecast in it, but probably should have been, and that has markets that have trouble dealing with change, at least in the short term. And I'll mention just a couple of those to start this off. In the energy world, we certainly have had dramatic changes in terms of the use of coal and the public support or the public rationale for having it over the last couple of decades. Take corn as a fuel source, and certainly the reaction and support for the corn industry for ethanol has changed over time. We certainly have a change in attitude and reaction to nuclear facilities. Thanks to a couple of accidents, we've changed the entire perception of the risk profile of those facilities. We had some imminent death of the fleet in any case. There was going to come a time when they were not going to be able to be relicensed, but it may be that we have hastened that by some measure. We have incomplete DSM, demand side management, that we once counted on as something that people would adopt just because it was a good thing. We've got certainly a lot of transmission line constraints that we wouldn't have had if we'd simply kept building to add capacity in order to match demand or to replace existing capacity. And we certainly see that in terms of locational difficulties for pipes. Witness the tremendous debate that's going on right now about whether to relieve some congestion around Cushing and allow the Canadian pipe that would come in and bring oil sands, a relatively expensive alternative for some of our older, more conventional reserves. Okay, let's just review the bidding. Energy, can't do without it, really. Fundamental, does a lot of work for us. Basically, you couldn't have modern society without energy. It's just not substitutable in any of its forms. Got to have it. But it has a characteristic that we've already noted, and that is it's very, very capital intensive. And every choice that we make as far as a capital expenditure in the energy world tends to be embedded and in place for long periods of time. Whatever characteristic we have, it tends to propagate itself and perpetuate itself over long periods. Imagine that you build a new house and you build it to the existing energy standards of the time. even with changes in fuel prices, that house is likely to continue performing at the level that it was designed over its lifetime. You will refit it, maybe only at your peril and only infrequently. So whatever we embed in this system that is responsive to energy tends to carry its characteristics forward over long periods of time. So we don't change this very fast in the short run. Now, all of the energy system that we deal with involves various levels of decision making. Whether it's a public official or regulator who approves a new application or revision of a tariff, or in fact a change of location for some facility, all the way up to investors who invest in these products, or ultimately the consumers who use them. At the decision-making level, we can say that for almost every decision that's made in this realm, it involves a high degree of probabilistic estimation of outcomes. You're faced as a decision maker, as a regulator, you're faced with a range of alternatives that each promise something slightly different and each anticipate a different outcome. Can't know these things precisely. Can't know what the demand curve is going to look like. We can't estimate how well something is going to perform. We can't even estimate whether the contractors will deliver what they said they were going to deliver when it's finally built. But we weigh all the options, make a decision, and at the moment that we make a decision and we, in fact, give permission to build something and it starts to get built, we've transformed that probabilistic estimate into a one-time deterministic decision. Now, we can operate the facilities differently after they're made, but the locational decision and the mix of characteristic investments, in fact, gets fixed at that point of decision, but in fact, all the way up to the point that they did get fixed, they represented some probabilistic estimate of outcomes. So that would suggest that if you wanted more flexibility in your system, you would always invest in something that had a characteristic that allowed it to either move or change its behavior or change its characteristics over time. But you might anticipate that you would pay more for that, which leads us to an interesting characteristic that is true of every single energy system throughout the world, even the ones that are not in a society that prides itself on democratic activity and choice, are controlled by price. So if you could pick an action that characterized your system, your energy system, whether it's gasoline transformation, whether it's oil and movement of oil back and forth, or natural gas, in the end, the decisions and the icon that defines the system are based on what we expect in a competitive society, price levels, but which cause decision makers in many cases to look at that and say, well, that's the one thing that in fact we ought to make sure doesn't vary very much. So the very thing that causes the system to be competitive and vital, that is its ability to either attract new capital or to respond to changes in demand. You'd like to be able to raise the price, wouldn't you, at times of really high fuel cost? But in fact, you have a little trouble getting that message out to the consumers because there's a lack of price transparency. So the very tool that you might like to have that would send signals is in fact taken away because we have an overarching characteristic of our power and energy systems that says lowest price is the best price. At the point of consumption, we want to protect the least amount of price volatility that we can get. And as a consequence, we miss not all, but we miss a good number of the signals that might tell us how to change the system, how to make it more responsive or more flexible, and we tend to even further embed technologies that reward that price signal and not the volatile one. So keep that in mind as we get on to talk about the implications of gas world if it actually happens. So the energy world, just a further word on it, it's actually two worlds, right? They may be converging right now, but there's two worlds. One's a transportation world based largely on hydrocarbons, and the other's an electricity world that's based largely on accessing either thermal resources, natural gas, coal, nuclear power, or hydro resources, the kind of things that we were able to tap, and that, of course, in the case of something like hydro, dominated some of our decisions about where to build, where to locate our cities, where to locate our conurbations in the past. So we've built out this duopoly of energy users based on the characteristics of the fuels that work best and also their location. All right, now let's go to gas for a second. Gas is an interesting commodity. We use it for lots of things. We use it to heat some of our spaces. We certainly use it for power generation, and we use it for fertilizer and some plastics creations. So it's been easy to get. It's been ubiquitous in many, many ways. I've got some maps just to show the aerial extent. And in a sense, it has also reflected the technological capability that we have to go get it. So if you look at this is adapted from one of the EIA early forecasts. I just wanted to have a picture of what we imagined gas reserves were like over some last 30 years or so. So look at this. These are forecasts of gas reserves, and they certainly show a decline going through the beginning of this century, this new century. And now all of a sudden, gas reserves are shown as going up. So part of that is pretty understandable. We have better ways of finding what's out there. Doesn't mean that there's any more of what used to be out there now. It just means that we know more about it and we can characterize it better. But part of this represents a recharacterization of something that we were having trouble getting at before because it was bound up too tightly. That's the unconventional gas plays, or shale gas, tight gas, areas that have not been or hadn't been thought of before. Now we've got some technological ability to go get them. And so the estimates, which is all I'm really concerned with here, the estimates or the forecast of what the reserves that were available has changed. And that estimate of change has changed how the markets imagine what the appropriate technology to invest in ought to be. Now, if we just take a second and walk over to the electric world for 1 minute, we can imagine that the electric world uses a lot of resources, right? A wide range of them. They use resources that run in a dumb form all the time. We can think of that as baseload power. It's running in the background. It's covering all the needs that are present every day, even weekends, even holidays, and they're running in the background. We like very inexpensive power to cover that need. It doesn't change very much. It's very predictable. In fact, it's so predictable that the behavior of bidding into that market is that it's useless to try and bid a competitive bid. We buy as much baseload capacity as we can, so the merchants bid in at zero. Right? They take the system average price. They get awarded the price that is assumed to cover their marginal cost. So we've got to move up the chain a little bit to find out what happens next, and that is that we've got to do some load following. So things change all during the day. We need different technology to address that, and we tend to incorporate where we can either more hydro, use hydro because it's a very fast responder, or we incorporate gas technology because it's relatively fast, it's very responsive, and it's pretty cheap when we've got a big base of it to deploy, to bring into play. Over the years, we have made more and more use of gas because it's been very flexible, at least in the power industry. And so these reserves have influenced how investment is taking place in the market. Now, when we look at where the unconventional reserves are, and my guess is that when this map is revamped 10 years from now, it's likely to look like this with some additions. They're widely distributed resource, and they reflect the opportunity to get at a resource that has been, let's say, second tier to a lot of other more attractive and easily acquired resources. But the bottom line is they're very, very widely distributed. In Canada, if we look at this map, we can see that the estimates have been pretty generous, at least as far as the Great Sedimentary Basin goes. But my real reason for putting this up is for the part that I left out, or that's blank, and that is the Northwest Passage and what's happening up under the Arctic. And so what I don't know about that, although what I'm beginning to sense, is that it's very large, lots of uncertainty with it, and lots of geopolitical interest in whether or not it could be accessed. So if I had a graph that went out and I said something happened in the Northwest Passage in 2020, and by the way, the Northwest Passage is going to be open at both sides this year for the first time. So you can get complete transit through there. And there's a number of companies that are very interested in going there, and I suspect they're going to be they may be looking here for some talent to go up and help them drill in some very unconventional space for wet and dry gas and for some oil reserves. So this might change dramatically just as a function of something that was uncertain 2 years ago and might be changed tomorrow. If I start to expand my definition out, then I can say that if I add coal resources and unconventional coal bed methane gas to the equation, I start to get more areas into play. And once I start to develop this into a comprehensive map, then suddenly I've got something that starts to get described as a play. So now I've introduced the concept that investors or companies that know what they're doing are going to be looking at this and saying, well, all right, what might be the best or the most accessible in a tier of accessibility resource that we could get? Maybe we ought to start looking at that. So I've just gone from a forecast, a USGS forecast, or something else that some of the petroleum geologists and the geological economists who are out there, like Andrew, might have said, we ought to look at that. And I've transformed it into something that now has a business plan associated with it, or wouldn't be called a play. So now I've moved into industry. Now let's imagine what's happened over time and look at what the estimates going out considerable length of time are doing in terms of shale gas, tight gas, pretty consistent but substantial estimate of what this is going to look like in the future. Anything political going on that graph? Going out anything hopeful and political going on that graph? Look at the net imports line. We don't like imports because they probably come from people that we don't like anyway, or that probably don't like us and would like to do evil things to our economy or something else. So we can be pretty optimistic that one of the benefits of expanding this is compressing this. So in a sense, this estimate from EIA also has a very strong political component to it. It's also designed to influence how markets behave and how they make decisions. But guess who else is reading this? There's another group of people who are reading this map and saying, well, I can do something different than what I've been doing. I might have a technology that I don't like, or that my constituency doesn't like, I might like to just say, well, here's the rationale for changing the way we do business elsewhere in the system. So now we might have, I can't assert whether this is an unexpected outcome from this or whether it's directive or not, but I do know that markets respond to information, and so do decision makers when they anticipate what could be available. So we've got a decision tree that I just want to introduce, and before I get to talking about what's happening on the ground with people actually changing behavior, and that is this, that we assume decision makers, who are my target here, behave responsibly. All right? So I'm just going to make the rational man argument that says anyone who is in a position of responsibility, an elected office, an appointed office, or some other area that can actually say yes, say no, is charged with acting responsibly. And some of that may come from a statute. Some of it may come from a revenue responsibility. And it also reflects the fact that anytime someone is making a decision, they are at least potentially either at the margin of everyone else making similar kinds of decisions, or they overlap. So in almost every case, there is some intended or unintended abutment or overlap of responsibility areas and intentions. Now, some of those, it's rare that you have an area that is left blank, as it were. It invites abuse, doesn't it? It invites people to come in and try and transform something in a way to gain economic advantage, to capture some scarcity rent that nobody else ever thought about. Why, that might be the Northwest Passage, might it not? So you can imagine some of the incentives for changing use up in the Northwest Passage by imagining what the control boundaries are and whether or not, in fact, there's anything that acts as in order to enforce the responsible behavior or some statute of limitations. Well, that means that intervention is also possible, and so I'm going to just suggest that we have ample evidence that intervention is not only possible, but that it gets used. So take something like hydrocarbon reserves, where we're going to go and change our characteristic of them based on what we can either take from a neighboring area or what we can exclude from being taken over time. We might imagine watersheds, a favorite. So if I'm developing in a watershed and I'm not worried about the downstream externalities on some other community, well then, and I'm not prohibited from doing it, costless to me, I might just take it upon myself to develop and capture some short-term rents from that and use them wisely for my own community, especially if I didn't have to have any negotiation with anyone else. But we might also have some lapses that happen, and here's an example of perhaps unintended lapses, and the idea of waste products in management. So I say the issue of nuclear facilities and sometimes oil spills comes into this, where we don't budget enough to cover something like tearing down a nuclear facility, something like long-term storage. If the issue of long-term storage of nuclear waste was big enough, then the incentive to maybe even open up an auction, just keep raising the price until somebody says, you know what, I own Yucca Mountain and I'd be pretty happy to take it here. Thank you. God, at that price, you bet. And so bring it on in. In fact, I'll build the train so that you can get it in here. So we've got decisions that often ignore some of the future costs, in part because we lack the overlap and regulatory authority to force people to act. Now back to gas for the end of this talk. One outcome of some of these increasing estimates of gas is an optimism that, wow, this is going to be a changed world, and we're going to have access to a cheap and very, very long-lived resource. So this is going to cause us to want to replace some of our aging capital at the margin with some of these newer technologies that are cheaper, but not necessarily with things that behave the same way the old aging capital used to be. And some of these, I said price stability, but it should also read that's resource availability. So some of the reserve estimates of how much is available bring a new sense of optimism. Change is possible, and the alternative is in our interest. But sometimes, along the way, some other outcomes intervene that perhaps force events. Let's just look at a couple of the more recent ones. So we had a tsunami, and it wiped out some coastal redoubts and flooded some plants, and certainly exposed more than just plant foundations. It exposed a number of errors in the behavior and safety systems of those facilities. Didn't do much to undermine the actual the engineering capacity or capability of those plants, but it certainly undermined public confidence in them enough so that the government was able to say very, very confidently, well, that's it, we're going to shut these things down. Don't need those guys anymore, it's too dangerous, and we couldn't trust the people that ran them anyway because they stopped bringing their political contributions in, and so now we don't need them anymore. And so guess what? This is an easy choice to make, because remember those gas reserves? Well, we'll just build gas turbines. We'll take all those old 737s that are parked out in Arizona, and we'll strip the engines off of them, put them on towers, and fire them up, and suddenly we'll have gas turbine world. And we didn't need those things anyway. What were they doing? They're providing base load, and now we can provide that same load with a different fuel, and it's just as cheap. Who cares? So some of the shifts that we've had, whether it's a system failure or whether it has been something that has changed the way that the system base is operated. Some of you may have heard talk that I gave. It was looking at some weather-related data from the Northwest, looking at the upper level wind patterns over the Columbia Basin. And you know that a lot of the hydropower that we get in the West, and a lot of the raison d'etre for having Bonneville Power Authority or for having the WAPA, the Western Area Power Authority lines, is that you got a lot of cheap hydropower. You can spin it and run it all the time. And so for a few years, it began to look like the 500 millibar trough that comes down and brings all the water for the Columbia River Basin and provides all that spin might be moving east, might be relocating itself subtly over time. And as it did that, there was, of course, an unintended outcome, and that unintended outcome was that you were getting a lot of that water somewhere else. And so I'm not going to speculate that that water actually fell anywhere else, like the Red River or Manitoba or the central part of the U.S., and might have caused floods that they weren't having before. I wouldn't suggest that. But I would suggest that if it did move, that's the kind of outcome that you might expect. And what a bad news thing, because all the capital facilities that were set up to deal with that issue, that is flooding, were inadequate. The water breached those low levees more easily than it did in the past. And if water wasn't revisiting in a pattern that provided the spin in the Columbia River Basin, well, then we had an issue, because suddenly all this huge capital investment that was set up to capture spin was pretty dry. Now, they didn't have this last year for sure, or this year, where they've got more water than they've got so much water to spill that in fact they have to truncate some of the contracts for the wind producers. But over long periods of time, there may be climate shifts happening that are going to change the nature of our installed capital base. So we're going to look at that and say, well, who cares? Here's an alternative to that. We can, in fact, just take on this new technology that's cheap and easy to get, and in fact is likely to be very ubiquitous in terms of being able to find it. So Japan has said, well, that's it. We're going to do that. And they have changed dramatically the short-term market for gas that will be brought to them by LNG. It certainly got Canada looking at where their products might go in the future. Germany saying roughly the same thing. They're saying it a little more broadly. They're saying we can replace a lot of our nuclear facilities. We don't want those anymore because if a tsunami knocks those out in the middle of Germany, then we're in trouble, and we don't want that. So in order to guard against that, we'll shut them down. Oh, by the way, shutting down nuclear plants is, you'll undoubtedly have thought of this, but you don't just shut them down. You don't just close the door and walk away and go, well, that's it, eyesore, but we'll just put up with plant trees around it. You maintain those plants for a very long period of time. Could be as long as 100 years. I don't know that. To be certain, it'll depend on the plant design, but it's certain that you will not just close the door and not maintain them. If you look at songs in Southern California, San Onofre Nuclear Operating Station, they've got one of the units shut down. Well, they monitor and run that. They literally run it at a low level all the time just to keep the system operating. So we don't just terminate some of these older technologies and replace them instantaneously. We have to, in fact, tend to them over time. France, a similar kind of event, except that they're saying that they're going to move back to coal. In Canada, in the zeal to embrace the new natural gas market and in a zeal to try and appear to be at least addressing or talking about some of the new climate goals, then Alberta has announced that that's it. They're going to phase out all their coal fleet. And they're going to do it in the space of what looks like about 15 years, depending on when the facility was initially constructed. Well, that's interesting. They've got a lot of natural gas, and they're anticipating that they will have not only enough to run the oil sands, but they'll have enough to run combined cycle gas turbines and provide a full range of power for the system. They did this in part, I know because I was part of the effort that looked at it, they did this in part because they were anticipating that the new reserves that were forecast to be available were going to be adequate and going to be priced sufficiently that they could do away with their coal plants. They didn't just say we're going to do away with them, though. They went the step that Japan, as far as I know, and Germany have not done formally to date, although Germany may have done it very recently, and that is they issued an order that said this is it. You will cease and desist. You will shut the plant down by a date certain, depending on what your operating characteristic is. So in anticipation of this abundance in natural gas, the government has responded by saying, well, we believe it. It's out there. It's real. It's going to be priced well enough. So we're going to take another administrative action that says, good, we'll take advantage of that. We'll build a lot of gas turbines, and we'll be very competitive. What if we overestimated the resource? What if those forecasts were wrong? Now, the USGS has recently revised some of their estimates of what the unconventional gas resource is likely to look like. I don't know what's going to happen with environmental constraints. My guess is that if we bid the price up high enough, we could actually come up with some sort of a clean operating coal plant. But that hasn't been an option, so it hasn't been attractive so far, and so we haven't done it. But what if we did? What if, on the other hand, environmental constraints came in and affected some of the estimates of gas reserves that we had? What if we couldn't get even the revised downward USGS estimate of reserves? What if some of the discoveries about the externalities of drilling for unconventional gas, whether it's in Canada, whether it's in Texas, whether it's out here, whether it's in Europe. What if those are employed and made into law? What do we do with a newly revised downward estimate of available natural gas? What if there's a change in some of our access points, either for imports from Canada, a place like Canada? What if we cannot get the other variable in all of this, and that is permission for surface access and processing? What if tomorrow every place that does unconventional gas extraction were faced with the requirement that they had to build a new water treatment facility designed to a different standard than what we've used since about 1950? What if that were the only thing that changed? What would happen to that gas estimate of reserves? Suddenly that reserve estimate would have an economic component that is not there today, and as a consequence it would have to be revised. So the question I want to raise as a result of this is, what happens to the value of what we already own? Right now, I'll tell you that the value of a coal plant in Alberta for the capital facility, whether it's one that was owned previously by a Canadian company or by Calpine, the forward price of a coal facility has gone down. Part of that reflects the fact that there's more interest in acquiring power from a neighboring province, in this case British Columbia, that has what looks like expanding hydro capacity, but in fact the forward price is for the plant is lower. What about the nuclear plants? I mean, have they all been written off at this point? Does everybody just assume that's it? We'll never have another one of these because we wouldn't want to go through that pain. Perhaps so. What about hydro facilities? The existing hydro facilities are at least in targets for reduction, the ultimate reduction, right? Taking them out, literally knocking some of the hydro plants out. So how can you have confidence to do that? Some of the hydro plants that are providing spin today, how can you even imagine going in there with a crew of dynamite folks and knocking them out? What about new transmission capacity? A lot of that is based on the idea that we'll have an increasing supply of some of these new sources. Certainly ports and pipes is a different category, but there's a lot of interest right now in getting new tidewater access for oil and gas facilities. A lot of that is based on an expanding estimate of what's available or what's going to be available in the system. So I'm going to argue that there is really a large-scale uncertainty component that is underlaying the planning system. And this is not the land use planning system per se, although it enters this, and I'll make that in my very last point. But I'm going to say that the very act of anticipating this new gas world has caused a fair amount of capital accumulation that we've got to be considered almost stranded. And the regulator may in fact categorize that as stranded assets that have got to be recovered some other way. And if it's not through the ratepayer, it'll be through the taxpayer, unless there are massive losses put forward. And we proved to be a little reluctant to do that with our lending institutions. What are we going to do with all those? And once we've devalued them, if the estimates change, if 2 slides ago what I was pointing out that says we're going to recharacterize the reserves that we had, how do you get these back? How do you bring them back into the system once they've been sent away? And isn't that an unanticipated cost that we should be thinking about long term? Well, with that, let me just remind you that when I started out, I started talking about different levels of decision making, and that we sometimes have difficulty communicating between those levels. Let me remind you that all of the levels of energy decision making, from the regulators who think they make all the decisions, to the land use authorities who actually can influence greatly the actual siting decisions of either generating plants, pump stations, straddle plants, access roads, visual impairment, and on and on and on. They're all depending on a set of information flows that in the end may prove to be imperfect. And we don't have not only a good way of incorporating that information into the basic decision-making process, so everyone is making decisions based on some common goal or a common understanding of what the outcome could be, but we also have some difficulty when we start to unravel the decisions that we've made and try and recover from markets that in fact devalue an asset based on a forecast, or devalue or revalue an asset based on an anticipated revenue flow. So my idea for trying to overcome this is to imagine that if we recharacterize the energy system so that it's clear at some core level what the benefits and costs of this system are at various levels of government or decision making, all the way down to the consumer. If we in fact involve each group in the overall decision making process in a way that they can see. For me it's monetized, but that's dangerous ground. So I will say, so that they can see or visualize what these benefits and costs are, then suddenly we've got a tool that can allow us to envision how these forecasts and how the changing future will impact some of their decisions. And maybe in the end of this, we will, by bringing a more comprehensive set of data or information, is probably most useful when it comes in as some sort of agnostic information, then we change the decision process, and I think we allow ourselves a little bit more flexibility in terms of dealing with something like Gas World. And it's pretty exciting to imagine, isn't it? Gas World, if it was in its end state, transforms the transportation world. Think of the benefit. Suddenly, no more transportation planners. Oh, sorry, I didn't mean that. I meant all transportation planners. So now, with Gas World extant through the system, might we envision that there's a weaning off of some of the hydrocarbon demands that we've had for liquid fuels, and that in fact some of the vision that we've had for an electric world might be realizable. And what's going to make that happen? Well, a confidence in the fuel source going out into the future is what's going to underlay it. And so the end of my argument here is to say that by not fully thinking out some of the, in this case just one tool, the forecasts, the exuberance of all new gas reserves all the time, we may have instilled a fatal flaw, or at least a short-term fatal flaw, that says we're going to put at risk some of our existing capital assets in the anticipation of a glorious new cheap alternative. One reason we did that, of course, is because the thing I outlined before, and that's price. Right? If the low price mantra is all you're thinking about, then guess what? You're going to only look for a technology or a deployment pattern that suits that. So I think it's by homing in on this idea of an expansive forecast based on incomplete information and perhaps some erroneous assumptions, we may have in fact put in jeopardy some of our long-lived capital assets and really put off decisions that needed to be made about refurbishing them, making them more efficient, or making them more effective in the existing system. And I think that is a danger that needs to be taken into account in our overall systems thinking. And that's my thought.
Thank you.
I'm open to questions. And I didn't mean it about transportation planners. They're my favorite people. They have all the best modeling tools.
2 points. First of all, in the early 80s, I recall that the Congress mandated the switch to coal. Was it called switch to gas?
Switch to gas.
Switch to gas, and that had unintended consequences.
Yes, it did. Well, it certainly opened the door for entrepreneurs to come in and take advantage of what were known as standard offer contracts and to get themselves hooked up to that umbilical cord for long periods of time, more than 20 years, and to be able to fund capital investments that they probably wouldn't have made otherwise. But it certainly provided, part of the intention was to bring more competition into the market, to bring smaller firms into the market, and it did that. Part of the objective was to bring alternatives like renewable energy technologies in. Now it may be, just one last line on that, it may be that one of the insidious unintended outcomes of all this is that if we had gas world in a very pervasive and substantial way, we might really just sound the death knell for something like renewables. It'd be pretty hard to justify supporting technologies that could be 2, 3, 4 times as much as the underlying fuel. When diversity didn't count anymore, your underlying fuel base was doing everything. It was doing base load. All you had to do was expand the installed fleet, and you'd be able to take care of all the peaking, etc. So, other than public policy, you might really put some disincentives in the path of alternatives like renewable energy.
Well, the second part is that as you were talking, the strong support for climate change and what it would do is sort of stranded assets. It's made it acceptable to say coal should be got rid of. Now, my question, particularly after being in Europe this summer, is if we can't afford that, then what happens to this? The climate change made it possible to have a sort of top-down, this is what it's going to be, we're going to get rid of this, we're going to do this. If all of a sudden it's thrown back, then we arrive at the situation you're talking about where people say, oh my God, coal is stranded and we actually need it. And because we don't want to be shutting down these power plants, cost too much.
Well, part of the issue of that is it costs too much to bring them back online, and that makes them a true stranded asset that you've got to pay for some other way, and it's unlikely, at least to me, that the rate base is going to carry that over any long period of time, and that only leaves one other source, and that's the tax base. And so by not leaving the option, by not hedging, as it were, a little bit, and the market tends to hedge, of course, when they're faced with this kind of information. And one of the ways that it does that is to send a risk signal about the capital. You can look at what that coal plant in Alberta is worth, which is 40% less than it was a year ago on the open market. So I don't know what, well, I don't even like to think about Calpine's books, but I don't know what they might have paid for it originally and what they might carry it for now. But I think those are risks that we would do well to incorporate in our thinking. Sorry. Whoa. Red, too. That's good. Green? That's good. Okay. Oh. Where are you guys? Where did everyone go? Yeah, well,
Other questions, anyway?
can I take any other questions?
Yes, please.
Once I planned it earlier?
Yeah, I think you did mention, the transportation sector. So in terms of transportation, and also you talk about the linkage between the land use. You said the land use for Canada actually had a very good influence because of siting. So in terms of now we're talking about this electrification of transportation system. So do you think this is really a political campaign, or you think really like within 20 or 30 years we are able to be able to say?
Can you repeat that last sentence, please?
So within the near, within the future 20 to 30 years,
Yes.
society is going to, for example, in the US, we are going to be able to switch like 70% of the private, the vehicle transportation to the electrified transportation. How possible is that?
Well, I think that it's probably, yeah, so my understanding of the question is that how possible is it to switch a substantial fraction of the existing private transportation fleet out into electric base vehicles. So I suspect the right way to treat that is to imagine, first off, how often anybody actually changes out from a capital investment like a car or a truck. In Canada, it's always a truck. And the bigger truck, the better. So,
You're from Calgary.
because you have to pay more for the truck, and that means it's worth more. So, okay, so bigger trucks. But you do it at the end of a lease period, so 5 to 6 years. And so, how often could we imagine the change out to be? If 50% of that fleet changed out, then we're looking at the potential to get a big uptick after 15 years or so. And then how much penetration? It probably depends on two things. One, what the control standards are for emissions, whether you can continue to run the old gasoline-powered or diesel-powered vehicle or not, and the performance characteristics plus price of the alternative. And my guess is at the point where the fleet starts to shift so that we've got 20%, if you could imagine that, 20% of virtually all battery-operated vehicles, or a next generation Volt, where you've got little tiny super efficient gas engine and a big battery, and the only thing the gas engine does is to charge that battery. Or the Lotus experiment, where you're putting all the drivetrain out right at the wheels, little tiny electric motors right at each wheel. Well, then my guess is that's the installed base that causes the full transformation, which probably means in the next 50 to 70 years, 70% are battery and not gas. And after that, my forecasting just fails. After 70 years. Crystal ball is... Yes.
Uncertainty.
Yes.
Seems to me.
I hate it.
Some of us deal with it as stock and trade, though.
Yeah. There you go.
It seems to me as though there are two kinds of uncertainty here. One has to do with not knowing what nature is going to do, and that really you need to represent, probabilistically. I'm not sure whether the decision makers actually do that to the extent that you've credited in your first slide. But the other is, what's the other guy going to do? The uncertainty about what the other players are going to do. And it suggests to me something I hadn't thought about before, which is the relevance of game theory to looking at all of this.
Yeah.
Multiplayer game theory, where you're looking at trying to acquire equilibria or establish equilibria among multiple players from different industries and different consumption sectors.
Well, exactly right. And I'll just say that one of my colleagues and I, Curtis Eaton at Calgary, have talked a little bit about this, and I'm trying to get him interested in asking the question, which is how I came to be talking about this topic today, about whether or not we could imagine the game outcome from changing forecasts of gas reserves and Alberta's invested capital base for energy. So we're going to take that question on. I don't know how well we'll answer it, but at least we can open the debate a little bit to imagine what's happening on a very big scale, and perhaps change the level of discourse for politicians at a national level who say, well, that's it, we're not going to have any more nuclear facilities. I'll give you one close to home example. We had MTBE is an additive, oxygenate for fuel, and we pioneered a lot of its use through the Air Board in California. And we had a leak up at Lake Tahoe. Of all places you don't want to have a leak. Oh my God. This stuff is extremely emissive. It moves like lightning through the soil. It just, it's agroscopic. It wants to go where there's a water source, like a drinking water source. Likes those best. And so there was a leak in Lake Tahoe, and it got discovered, a lot of press about it. And so we started to dig into it and find out, well, what happened? And because people were saying, well, the tanks failed, this is a stupid thing, we shouldn't have this horrible carcinogen lying in the soil, and we should do something about it. Well, as it turns out, it had everything to do with the pipe fitters union and the standard that they imposed on controls for how they did fittings. It had nothing to do with the tank, and it certainly didn't have anything to do with this horrible carcinogen, which we have a lot of in the country, right? We store some really horrible stuff, but we do it pretty safely. And I hope I'm getting to the question of uncertainty here just a little bit in this. And that is, at first it was not clear what had happened, but there were a lot of alternatives. The tank could have failed. Something could have blown up. Could have been a terrorist act. Somebody spilled it. Somebody shut down the substation by mistake and blacked out the entire Southwest. Something happened. We didn't know what it was. Well, we clearly did not understand the risk at all, and the risk turned out to be a political risk that was totally unanticipated. 2 days after the spill, the governor of the state of California got up on the podium and he was talking about, I don't know what he was talking about, welfare or something. He said, oh, by the way, I've issued an executive order this afternoon and we banned MTBE from California. We will no longer use MTBE as of, well, 5 o'clock today. What? So suddenly, every tank full of MTBE was redundant, had to be taken out. We had no idea what caused the problem in the first place. We had no alternative to replace it with. And in fact, we had not reduced the level of uncertainty at all. All we had done was introduce a new level of uncertainty, which is what is he going to do next? And what's going to happen to our market? And what will happen to the folks that supplied the product to us, the Canadians who made that product, and they cratered because they didn't have anywhere else to sell it to. And in the end, what the governor said was, there must be something else. I don't know. We don't use that stuff. Well, the something else was change the oxygenate standard and get sued by the federal government, but buy some time that way, I suppose. The other alternative was to find another one. So we found another one that turned out to be just as toxic, but it had the side benefit of rewarding everybody in Iowa who grew corn by a subsidy from the check from the state of California. So sometimes we don't take the time to characterize these things in the public forum, and it makes a lot of difficulty in terms of translating what you think you know into an action that, in fact, then influences widely markets. So we stranded a lot of assets in that little exercise. Am I done, Al?
I want to answer.
Al, step up. Look.
I want to answer your question. That is, I like your suggestion about making information available to people at all levels, and that you just alluded to that just now. How we get a start on doing that, or moving it to be more like that?
Well, first start is, of course, have more economists to work on the problem, because that's a full employment act right there, and it's a good thing. That's a great thing, in fact. So I'm going to argue that a way to start doing that, we all consume data, all of us, the students, the professors, we generate data, we consume it, and we transform it in one way or another. And most of the time, I'll say, except when I'm dealing with some other faculties, I can understand what people are creating. I certainly, if you reduce it to the maths, I get it. or I can at least follow the logic. But my guess is that as we go higher and higher in the decision-making tree, the understanding level either decreases arithmetically or maybe even exponentially with that kind of information. So I'm going to suggest that since we have a lot of data, and since we have a lot of knowledge about how things work, that we ought to spend more time playing games. And I'm going to bet that the right thing for us to do would be, especially in the econ department, would be to start to go back to Google and to some of the, who are the people that make the little pod with the, is it we? So there's a company up in Canada, and they have, I don't know, 2 acres full of people whose sole job is to create software that plays games. They play games all the time. And they're always dreaming up new things. What I had proposed to my department head, and they pushed me out the door, was that we might want to hire 1 or 2 of those folks as visiting fellows and get them to come in and play games with us. And my objective would be to have the people who will play the games be the people that you're just talking about, and say, tell me what you understand about this. What did this do for you? Play my game. And you show me that you benefited from it. And if you can't, or it's just lights out, well, then it was the wrong game. Because somehow, if we don't start translating what we know in a faster way out to people who actually use it, we're in trouble. Because we're going to get lots of unintended consequences and lots of on-echelon changes that are going to be very difficult to control at the outer margins. So I think reinvent ourselves, and my idea is to bring in a lot of Hasbro programmers who might be out of work. And am I out of time?
No, he's the guy.
Oh, he's the guy. Okay, so you're hired. I have money, so I can hire people. Andrew.
Is there any way of increasing the stake that people have in the future of the consequences of that act? The companies who take a position. I'm thinking actually of the financial crisis that have gone through, where banks did not have a stake. Can you make an analogy at all within the energy system?
Yeah. So let me. Okay, and I know I'm out of time, but I've thought a lot about this, and I think about it in terms of the risk of energy activities that are simply not covered because we didn't think of them, but because when they do occur, we're not covered in one way or another. That says to me that we don't price the resource well enough, and so one way to compensate for that is to force a kind of insurance on the operator and let that insurance price filter down through the system and become more closely associated with what we consume. And I'll give you one example. We have some drilling activities that go on in areas I'll just say in California, certainly in Alberta, and in fact, I'll just make this an Alberta example. One of the ways that the oil sands works today is because we have either a zero marginal cost or close to it for storing polluted, horrible water. The way we do it today is that we require people to clean the water up to the limit of the economic benefit. So a lot of those constituents of the tailing water are really valuable, and the companies would like to get them back. And not have to import them from somewhere else, diluent, for instance. But there's a lot of other exotic chemicals that they'd like to own again. And the regulations require them to clean things up to that point. And then because they don't have a good way of dealing with some of the residuals, they're allowed to store them out in big tailing ponds that are pretty, have a broad areal extent, and the requirement is to store them until it becomes economically feasible to deal with them. Well, that's, let me think. I'm not ready to deal with that yet. Its connection's really bad. Yeah, that's the I'm in Jamaica, yeah, but I'm not ready to deal with that yet. It's too expensive. I'll get back to you. So the regulator left a bit of an open door when they exposed this, but it's an important industry in Canada, certainly, and one of the ways that it has become competitive is by allowing them to have a lower unit cost by some of the practices that they take on. So, suppose I said to you that if that water ever got in the Athabasca River, which flows south to north and ends in the Arctic Ocean, which, by the way, just happens to drain both to the Atlantic and to the Pacific Ocean, and that I'm assured by the water quality engineers who work for Nexon and some of the other companies, Suncor, that in fact, I had an unbelievable conversation with the chief engineer of one of those companies, and I said, well, what are you going to do in the event of a breach in the dam? And he said, there's not one. We won't have one. We can't have one. That's why we engineered it the way that we did. I said, 100% probability, or 0% probability of a breach? He said, absolutely. Can't fail. Well, boy, I mean, if I propose what I'm just about to propose to you, it would be a pretty cheap fix, because what I'm going to suggest is that if we take a lesson from the insurance industry, my friend Evan Mills at Berkeley does a lot of work on this, and say, okay, I believe you, but in the 1 in 5 trillion chance that it does, as unlikely as that sounds, what would happen? Well, of course, the damage potential is almost infinity. So, pretty big range, right? And so we're going to settle on something in the middle based on an actuarial, and I'm going to require you to post a bond. And every year that it doesn't occur, I'm probably, if I keep the same table, I'm probably going to ask you to increase the bond, right? So what's your incentive? At some point, the cost of increasing the bond is going to outweigh going in and doing something about cleaning that up. If I price that bond right, if I think this out, and I look at drilling activities or storage activities or even some consumption activities, I've got the economic tool that makes this work. I can require people to bond up effectively to represent the damage control, and if it's too much, guess what? We'll get a different technology. I'm going to stop.
Yeah, I think we better stop.
Thank you. Thank you all for having me. Appreciate it.
And Michael, on behalf of the engineering program, I'd like to give you a couple of very small gifts. Systems engineering.
My own sweatshirt. Now we're talking. I waited for this for 3 years. Yes. Thank you.
Okay.
Thank you all. Thank you all for coming.
Yes, thank you.